Hi everyone. Good evening. My name is Blessing Oladeji. Um, and we appreciate it if you let me know whether you can hear me. So can you hear me, please? Can you notify me if you can hear me? Can you hear me?
I
Yes,
can.
I
Okay,
can. I can. Eric Ogidi can hear you.
okay, great. Thanks a lot. Thanks a lot. Okay, so let's get started today. I do not. So most of the time when I take this class, 2 hours is always not enough to take this class. But yeah, it's good we just get started. And I'll start with a recap of what we did last week. So last week we had um,
The voice is distant. Yeah, can you
okay, thanks. Okay, so last week we had an introduction into big data, and then by the time we're going to end last week, we started with the technologies for handling big data. So I think we would continue today's class with the technologies of handling big data, and that will lead us into one core concept of modern big data technology, and that is the Hadoop framework. Once again, I want to welcome you to this class, and I hope you would enjoy. I hope you enjoyed the class. Um, as most of you know, my name is Blessing Oladiji, and I'm taking this class from Abuja. I traveled to Abuja on Wednesday, and eh, we have a project in Abuja, so I'm going to be transmitting live from Abuja this particular weekend. But notwithstanding, there's always going to be on-ground support in our office in Yaba. Emmanuel is on ground to support you. We expected some people to come into the office this week, but we didn't see them, maybe just because of their busy schedule. But notwithstanding, you are always going to have me available anytime you need my support or you need any of my team support. Um, so this evening we are going to continue on the technologies of handling big data. Last week we look at big data, the characteristics of big data, the technologies for handling. We also spoke about the technologies for handling big data uh, last last week Saturday. Uh, we talked about mainly the characteristics of big data in terms of if something that will characterize big data would mean that the data is um, there are three core V's that characterize big data. One is the volume of the data set. The other one is the velocity, that is the rate at which the data set is changing. And the third part is the uh, the volume, velocity, and variety. Yes, the variety of big data. We talk about the applications of big data across different industries, and there's clearly no end to how you can apply big data. If you talk about agri business, insurance business, energy business, whatever, any point, even in population distribution, big data is always relevant. We also look at evolution of big data, um, how different characteristics of big data is driving a different kind of technology for big data. So starting from the velocity. So the rate at which data was changing sometime in the 60s, and they developed the relational database technology. Then later on, there were different varieties of data sets, and due to different varieties of data sets, the engineers of those times in the late 90s to early 2000s, they developed like they developed no SQL technology to handle unstructured data sets or varieties of data sets like email technology, videos, picture, etc., etc. But more recently, the fact that the volume of data keep rising at exponential rate. In fact, it is believed that the data that have been generated in the past 2 years is more than all the data that have been generated 10 years before the past 2 years. And it's very intuitive to understand that because the type of mobile phones that we have is you collect a whole lot of data with your mobile phone and then keep uploading and keep treating yourself to it. So that is how all the Hadoop technology. And we are going to spend a lot of time this evening talking about how that Hadoop technology, what it looks like. But to start, let's do a quick recap of some of those things that we spoke about last week. So last week Saturday, we also spoke about the concept of distributed computing. And I like the example I gave last week. I'm going to give that example. So when you look at the concept of distributed computing, like when you have multiple computers that are connected together within a network in a way that facilitates distributing of the task across all of those computers. Very good example that I'm going to a very good use case. So example that I'm going to give you by you looking at say there are 1,000 people, have 1,000 people that want to send Abuja from Lagos, for instance. You can take them to the train station in Yaba there and get all of them onboarded on the train, and they all travel from Lagos to Abuja. So they go through the train. Any one of them want when any one of them is hungry along the way, if any one of them is hungry along the way, uh, the train will have to stop along for that person. After the person, then anyone wants to say, there is an emergency, so by the train will have to stop for that person. Any of these 1,000 and not the person that then you can imagine how that
Sorry, your voice, your
right.
sound quality is very low. Your sound quality is
Oh, my
very,
voice
very low. I can
is
hardly
very
hear you. Yes, sir.
oh. Okay, so but is that peculiar to you or is general to everyone?
It's breaking actually.
Oh,
The
it's
quality
breaking
is
actually.
It's breaking and it's kind of distant.
Okay, so let me see if I can fix. I'll quickly see if I can fix that.
Yes, please take your voice
better
close to
now.
the mic.
Better.
So just a minute. Thanks for giving me that.
Thank you.
Okay, so uh-oh. Okay, okay. Hi, please. How do I sound now? Do I sound better now?
Yeah, it's a lot better.
Okay, thanks a lot. So I've kind of improvised. Okay, so I'll just start all over. I'll just start all over again. So as I said, we are looking at we are doing a recap of what we had last week Saturday. So last week Saturday we talked about distributed computing, and the concept of distributed computing, it's like having multiple computers that are connected together in order to be able to share the computing resources of all of these computers, and in order to be able to divide the tasks among all of these computers. And I was trying to give an example. So you imagine a big data job that it's like, I'm trying to relate it to a problem of trying to commute 1,000 people from Lagos to, say, Abuja, for instance. 1,000 people, that is like a big problem. How do you solve that problem? You can decide to take all of them in a train and convey them from Lagos directly to Abuja. So with that, at least you can solve that big problem. But there's a challenge with that, and the challenge with that is that if someone has an emergency situation in the train will have to like pause so that that person is attended to before the train continues. If anyone is hungry in the train, at the next available terminal, the train would have to wait for that person to come down from the train and have some lunch or dinner before train continue. So you can imagine if 1,000 people are leaving from Lagos to Abuja, you can imagine how long it would take to move them from Lagos to Abuja with all of that dependencies. Another way we can solve that problem is by looking for a number of vehicles. So we could look for like maybe 200 vehicles, for instance, 200 cars. And you can imagine the cost of, so you can look for 200 cars and then share the 1,000 people into those 200 cars and then take them to, and then they take off from Lagos and they go to Abuja. So you imagine those two scenarios. Now, if anybody has any emergency situation among the 1,000 people, the whole 200 cars don't need to stop along the way in order to be able to attend to this particular person. It means it's probably just the car that has that person that has an issue that will have to stop. Then also imagine the cost of a train. So imagine the cost of a train. The cost of a train with maybe a number of coaches will be significantly higher than the cost of 200 cars. I'm just thinking, but I think yes, I think that is just the case. The cost of 200 cars will not be as much as the cost of having a train that with a number of coaches. Now, that is also the same thinking that the developers that they had in their mind when they came up with the concept of distributed computing. So when there's a big data problem, that data can be distributed among a number of small computers. And from research, it's believed that that job can be executed a lot faster when it's distributed among a number of PCs than if you have only just one big supercomputer that had to get the job done. So that is how they came up with the concept of distributed computing. So it is faster. So with the idea of train taking 1,000 people, if a train is taking 1,000 people to Abuja, for instance, if the train breaks down along the way, it means the whole 1,000 people would have to stop until when the train is fixed, you know. But if 200 vehicles are taking 1,000 people to Abuja, if there's a breakdown, it's probably just one car that is going to that will have to the car that is affected that will have to stop. So you can see that with that thinking or with that concept, when the tax is distributed among many commodity servers or many commodity computers, the job gets done a whole lot faster. Then also, okay, so there's more processing power. There's more processing power. So instead of having only one single engine, in case of a train, instead of having only one engine, dragging the 1,000 people from Lagos to Abuja, you have like 200 different engines that is moving people from Lagos to Abuja, even though they are smaller engines. But you see that when all of those power from those engines, when they are combined together, you get a lot better performance. So that was how we conceived, or that was how the big data problem itself is solved with the concept of distributed computing. That was one of those things we talked about last week. We also spoke about parallel computing last week. And parallel computing, it's a case whereby you have multiple processors that are attached to just a computing device. So some of us, when you buy a dual-core processor, your computer has only one memory, but it has two processors that are attached to it. It is the concept of parallel computing, where you have a computer that has multiple processing units. So when you have a job that needs to be done, there are multiple processors that are getting the job done, although it is still one single computer that is doing the job. So how you conceive that is when you see an aeroplane, you can have an aeroplane. An aeroplane has like twin engines. You know, an aeroplane has two engines, but it is just one single aeroplane. So when you see the guys that develop big data concept or the computing concept itself is what they have observed from everyday life. That is what they have used in developing all of those concepts. So you have an aeroplane. Aeroplane has 2 engines, but it is just one single aeroplane. So in case while the flight is while the plane is flying, if an engine fails, it does not mean that the aeroplane is going to come down. The single engine that is functional can still take the plane to the destination. So that is the concept of parallel computing. So every other thing is shared. Every other thing. So all the processing units share the memory space. So the aeroplane fuselage can be the memory space. That is where people sit in the aeroplane. That is like the aeroplane fuselage, while the processing units are the engine in an aeroplane. I hope I'll come back to this later on, but those are some of the things that we discussed in the class last week. So in terms of architecture, this is what the picture of distributed computing, this is what it looks like. So in distributed computing, you have like so when you see a processor and a memory is like a computer. A processor and a memory is a computer. So the distributed computing have a number of computers connected together within a network, and whenever there's a job that needs to be done, the job is shared among all the processing units. Whereas in the parallel computing environment, you have multiple processors that are sharing a memory unit. So but these are concepts that were introduced not to handle big data job. When there's a big data job that needs to be done, these are concepts that were introduced into computing in order to be able to handle it. So when there's a complex job that needs to be done, the complex job will be divided into smaller tasks, and then there will be a piece of software that will now go and check, okay, the job has been divided. How many resources do you have available? Resources in terms of how many processor and memory, how many computers within the network, within the distributed network do you have that's available? So the job is now assigned, the available job is now assigned to each of those computing units. Very, very simple, very, very simple concept. But however, there's a problem with that, and the problem with that is what they call the problem of latency. There's a problem of latency with that. And what is latency? Latency, it's like I'm coming. My PC looked a big dim, so I'll take it. I want to take it back a little bit. So where is it again? Just a minute. I'll get it sorted now. Okay. Okay. So yes. Okay. So as I was saying, there is a problem of latency with the concept of distributed computing, and that latency means that, see, you have so there could be delay along the line. So even each of those computers that are connected within the network, each of them could have some small delays here, and there could be small delays here and there due to maybe breakdown or waiting for a particular job to be completed. So latency, it's like the aggregate of all of the different delays that have happened within the distributed network. So again, how did we decide to solve the latency problem? It's just very simple. To solve the latency problem, we can set up parallel computing into a distributed network. So you have a number of parallel computers that are connected into a distributed network. So instead of having one memory and one processor, you can have multiple processors and a memory as a single unit connected with another multiple processor and a memory. I'll try and relate this in a very, very layman way so that it does not look too technical. I know there are a lot of people with different backgrounds on this call. So, so again, cast your mind back to 1,000 people that have to move from Lagos to Abuja. So the original problem is that you can take them in a train. If you take them in a train, it will take a longer time for you to have those 1,000 people get to Abuja. And if the train breaks down, it means that everybody would have to like wait until when it is resolved before they can get to Abuja. So we try to like form the concept of distributed computing where all of those 1,000 people, they are distributed into like 200 vehicles. So when you distribute them into 200 vehicles, at least you can get people to Abuja faster than how a train would get them to Abuja. But now we now said, okay, so that is one problem. That is one solution to the problem. That is distributed computing solution to the problem. The other solution to the problem would be, okay, why not fly them in an aeroplane? Aeroplane has twin engine, and because it has twin engine, it can move a lot faster. So those 1,000 people, you can ask them to go to, you can ask them to travel from Lagos to Abuja. So maybe the aeroplane has capacity to take 200 people, for instance. If aeroplane has capacity to take 200 people, you can take those people to Abuja 5 times, so the aeroplane will just have to go 2 times over because aeroplane is like a parallel system. It has multiple engines and it can fly and can move a lot faster. Now, so which is a second solution. But then we still had some little delays because at times when the data gets so big, in some cases, you may also have some little delays along the line. So is it now possible to now take all those aeroplanes and connect them in a distributed network? That means instead of having only one single aeroplane taking the 1,000 people to Abuja, can we get like 10 different aeroplanes to take all the 1,000 people to Abuja? So you can imagine how fast we can get if we use 5 aeroplanes to get 1,000 people to Abuja. That is how they were thinking, and it's achievable with computer. So that is simply how they also solve the problem of latency, is by combining the concept of parallel computing and combining the concept of distributed computing together within a network. So with that, they could get job done a lot faster. So how you imagine it is that all the emails in this world that is sent on Google, all of them, they are stored on a particular server. But in case you want to check the email that somebody sent to you in 2018, just log into Gmail and just search in the search bar. In less than 1 second, your email, the email that someone sent to you in 2018 is just going to appear. So what made that possible is just the concept of parallel computing and distributed computing put together that made that possible. Please feel free to ask me any question if it's too technical before I proceed. Ogidi, Eric, please, your hand is raised. Eric, can you hear me?
Yes, I can hear you. I raised it when I was going to tell you about your voice not clear.
Okay. So do you have any question?
No,
I'm raising my hand concerning this now.
Okay, please. Anybody that has a question, please feel free to ask.
So can you hear me, please?
Very well.
Okay, so good evening. You gave an instance of using a train, and if it breaks down, everybody will not get to their journey. They won't get safe to the journey, and you decide to break it down maybe into 20 vehicles. So now let's assume one of the 20 vehicles breaks down. Part of the people will not get to the journey. So in a situation like this, is it not possible that part of this, even after breaking it down, will not get to the destination? What happens in a situation like that?
Okay, so thanks a lot for that. So in a case where a vehicle breaks down, the fact is that it's not everybody that is delayed. It's just some of the 1,000 people. So if a vehicle can take like 5 people, for instance, it's only 5 out of 1,000 people that will be delayed. It still means that the job can still be done. to a large extent, unlike in the case of a train where if there's a breakdown, the whole 1,000 over 1,000 people it does not get to the destination. You understand? But in case of a car, at least it's only maybe 5 people that will be delayed. And in that case, you can easily also find another car to transfer those 5 people into them. But if a train breaks down, it will be difficult for you to find another train to transfer 1,000 people into the train. So those are the thinking that came alongside with the concept of distributed computing. Does that answer your question?
Yes, thank you.
Okay, thanks a lot. So please feel free, if you have any other question, you can ask me if you have any other question. So in a distributed computing work, how it works is that so there is a job. It's a big data job. It's a big data job. It's a whole lot of data. We gave example of some kind of big data that you might think of. So if the user invokes that job in this diagram, the user through his PC is invoking that big data job. So how the computing device, how it does it is that it breaks down the job into a number of tasks, into smaller tasks, and then assigns it to the distributed computing environment. So the different computers or the commodity computers within that distributed network will take each of the tasks and execute it, and then the result is combined together once the job is fully done and returned back to the user. So that is how distributed computing network, that is how it simply works. Then we also spoke about parallel computing. Parallel computing can be implemented in a variety of ways. There are a number of ways that parallel computing can be implemented. And the idea about parallel computing is just because when there is huge data, or when the rate at which the data is changing, when it is very, very fast. So you might also need like a parallel system in order to be able to handle it. And I gave that example of a parallel system can be compared to an aeroplane that has multiple processors or multiple engines. So because of the multiple engines, it can actually fly, it can move a lot faster. So even if aeroplane is not flying, for instance, imagine there is a road that is designed for an aeroplane and the aeroplane has to run on the road. You can imagine the massive speed that the aeroplane is going to be running. So parallel computing comes in form of a cluster or grid, and that has to do with a number of servers that are connected in a network so that the workload can be shared. So parallel computing can also go into what you know as a distributed computing network in form of a grid or in form of a cluster. So grid is usually more cost effective and it works a lot faster. Then parallel computing can also be implemented in form of what they call MPP, that is massively parallel processing. What that has to do is that you have a single computer, but that computer is simply working like a grid. And when I say working like a grid, one single computer that has multiple processors in it. So in some of us, we already have PCs like that. You have a dual core processor. So if you have a dual core processor, mute your microphone. Yeah. So if you have a dual core processor, it means that your computer has 2 processors that are in operation, at any particular point in time. There is what they call quad core processor. For computers that are quad core processor, it's like 4 computers that are working in it, and so on and so forth. So sometime last year we did a project with a company in Lagos. That company is called NISS, Nigerian Interbank Settlement System. So for that particular project, we had to customize the computer that we needed for that project. So what we did was that we bought like a 16 core. We bought a 16 core server. And when they say 16 core server, what it means is that there are 16 processors that are in that server. So when you go to Computer Village and you want to buy a server, they can build a server for you that has 16 processors that are in it. So when somebody from the outside is looking at that computer, he's thinking that it's just one single computer. But no, it's not one computer. There are like 16 processors that are inside that computer. And for a lot of us that work in corporate organization, those are some of the servers that make your ERP application to be available. Like if you go to a bank, the bank server, so how is bank able to do it that like across like 500 branches? Tellers are connected, cashiers are connected to a server. They are connected to the back end and they can post transaction and they can submit transaction. It is so those transactions or those data sets, they are stored on a PC that can be like a massive parallel computing server, you know. So they have multiple processors in them. So as different cashiers are submitting their transaction or posting different transactions, the server will be able to take all of that. But when you look at that server, it's like one single computer. When you're looking at it, it's like one single computer. But in the recent, there are like multiple processors that are in it with multiple storage and multiple processors that are getting the job done. Then the third concept of parallel computing is what is called the high performance computing. And the way it is that I'll take you back a little bit in order to be able to explain this concept. So if you look at this unit, you see my mouse moving. So this single unit is like a computer. This unit is like another computer. There are three key things that make up a computer. One is the processor, the other one is the memory, and the third part is the disk. But the core part of a computer, what they call central processing unit, CPU, is made up of processor and the memory. Those are the core part of a computer. Now, the processor is different from the computer. So there's usually back and forth. There's usually back and forth between processor and computer. There's usually back and forth between processor and computer. So those back and forth between processor and computer, over time, when you have a big job to do, it can result into delay. So they now thought about what they call in-memory computing. That is it possible for us to have the memory on top of the processor, to design the memory in such a way that it's inside the processor itself. So that's what they call in-memory computing. So that is going to minimize the back and forth between the memory and the processor. Then, so I'm going to also explain that one in another layman way. So look at a train, for instance, going from Lagos to Abuja with 1,000 people, but there is no canteen. There's no canteen on that train. And because there's no canteen on the train, it means that anytime that people want to eat, the train will have to stop at a terminal so that people will eat. After people finish eating, then they will get on board on the train again, and the train will continue going. If another set of people get hungry again, after maybe 200 kilometers or 20 kilometers, the train will have to stop at the next available terminal again. So why not, instead of having that, why not have one of the coaches and convert one of those coaches into a canteen so that the train doesn't have to stop anymore? So anytime anybody wants to eat, they will just go to the canteen that is on the train and eat their food, you know? So that is the concept of in-memory computing. So instead of having back and forth between the memory and the processor, let's have the memory on the processor so that the job can be executed a lot faster. So that is the concept of high performance computing. That is how they design high performance computing. Some of these things, they are part of our everyday life that is built into computer technology. So those are some of the concepts that facilitated managing or that help to manage big data. So as data grow bigger and bigger and bigger, distributed computing, parallel computing, or a combination of both of them can help us to get job done a lot faster. And that's why when you go to the internet, you are searching for something on the internet. So I'll just do a very small example. I want to search for food on the internet. For instance, I'm searching for food on the internet. Food. Food. Here is food on the internet. So how many results came? I have 8.5. Is this billion? 1, 2, 3. 8.5 billion results came in 0.72 seconds. How is that possible? It's just this rare computing. So the results, all of these results that came, they did not come from a single server. They came from multiple servers. So it's not like it is one server. It's not like one Google server is returning all of these 8.5 billion results at once. No. But because the query itself is sent across all the different computers that are connected on the internet within the Google platform, and then all of them return back the result in less than a second. That is what made that possible. So you also imagine if you're working with a bank, a GT bank that is processing more than 200 million transactions in a day, over the counter, USSD channel, internet banking channel, ATM channel, POS channel. All of these, they are hitting the server at the same time. How are they able to manage all of these requests and they can get your transaction processed as quickly as possible? It is this concept that we are talking about that made all of that possible. Now, I want to move further a little bit. There is also another concept of big data, or there's another concept of computing that made that made processing big data, that made it very possible. So cast your mind back to the example I gave for the project that we did at NIBS, where we had to like couple a computer that had 16 processors in it. So you have one single computer, but in the real sense, it's like maybe 16 different computers that are connected in one. So how would you now manage it in such a way that multiple people can connect to that computer? So what they do is that they use what they call the concept of virtualization. And how virtualization works is that you can take a computer and divide one computer into multiple computers. So so for those that are connected to this class now on a PC, not a phone, even though it's also possible to get it done on a phone. So imagine your computer now. So we can divide your computer into like 4 computers in such a way that different people are going to log into your computer and they are going to be working on the computer as if they are the only one that is working on that PC, but there are multiple people that are working on that PC. It is the concept of virtualization that makes that possible. And for those that have registered for this course, if you've downloaded the virtual lab environment, that virtual lab environment is like a virtual computer. So it will make your computer to look like another computer entirely. And you can have multiple virtual machines on a particular computer. So you can have like 2 or 3 people connected to a PC and they are working on that PC as if they are the only one that's working on that PC. But in the real sense, there are multiple people. So you have one physical infrastructure, but multiple users connected to that physical infrastructure at the same time, and they are working concurrently, you know. So that's how virtualization works. So what it does is that it separates the physical layer of the computer from the resources that are available on that computer in such a way that it appears like multiple computer, but it's just a simple computer. So what this does is that it adds another level of efficiency, you know, to the IT infrastructure. And in the project that we did, we wanted to buy like 3 servers. I think I have the architecture somewhere here. I can quickly run you through that architecture. Where is that architecture? Here is that architecture. I'll share my screen.
Sorry to cut in. Is this in any way related to like any desk?
Yes, it's related to any DEX. Yes, it's related to any DEX. I'll come to AnyDesk soon. Let me just share this. Let me share this. How do I stop my screen? Yes, so I'm stopping this, then I will share my desktop. Yes, so this is my desktop, and where is this technical? Not this, not this. Okay, so this is what I want to share with you. So in this particular this is like the architecture for that project. You have, so it's a bank. So imagine like GT Bank. GT Bank runs on Finacle. So you have Finacle. You also have like a CRM application that is called Salesforce. They have a loan application that is called Infoware. They have Oracle Financial Suite, which is like their ERP, and for human resource management, Oracle Financial Suite. So these are the data sources. These are the platform that they own in GT Bank. Now imagine Octave Analytics. Octave Analytics want to do a project with GT Bank. So we requested for 3 servers. One server is going to be the staging server. Here is the staging server. The other server is going to be the master data platform. Here is the master data platform. This one in red. Then the third server is going to be a visualization server. Here is the visualization server. So when we wanted to do that project, we told them that, okay, we are bringing 3 servers. They said, no. That in their server room, they don't have space for 3 servers. That we should go and bring only one single server. So how would you use one server to serve like 3 different servers? So it's the concept of virtualization that makes it possible to do that. So how it works is that, so we intended buying like 8-core processor for each of these. 8 core. But instead of buying 8, so one computer that is 8 core, another computer that is 8 core, another computer that is 8 core. But they said they don't have space to take 3 computers in their server room. So what we did was that we went to those guys in Computer Village. We said, see, build a server for us that has 64 cores. So 64 cores is going to be one physical infrastructure. So it's going to be one physical computer, but in the real sense, they are like 64 processors. There are 64 processors that are connected to that physical infrastructure. So what we now did was that we now use a virtualization tool, a VMware. It's like a VMware, or so they call it, one of those two is called VMware. We now use a VMware to partition that computer into 3 different computers. We partitioned it into 3 different computers, and then people will log into one of those 3 computers as if they are just on that computer alone, but they are not the only one that is on that computer. There are 2 other different computers that are on that one single computer, or 3 different users that are connected to that computer. So TeamViewer can help you to do it for people that have used TeamViewer before. So if I have TeamViewer on my computer now, I can be working on my PC, and somebody else that is in Abuja or somebody else that is in London will log into my computer, and is working on my computer as if he's just on the PC, as if he's physically there, but in the real sense, it's not there. It is TeamViewer that they used to do to manage all those electronic billboards. So if you are traveling on 3rd Mainland Bridge, you see electronic billboard, and you see some videos playing on those billboards. So it's actually through virtual computing. Hello. So I'm hearing. So it's through virtual computing that somebody that is at a remote location can log into those billboards, and then maybe update an advert, or shut down a particular advert, or reboot the system. It's through virtual computing that some of those stuff is done. So what we did in this project, we needed 3 servers: server 1, server 2, server 3. but we combine all of those servers into one single physical infrastructure. We now use a software, a virtual machine software, to divide that physical infrastructure into like 3 different layers, and different people can now connect into each layer as if they are the only one that is on the server. So I think that explains it. Please, if you have any question, please feel free to ask me while I switch my PC. Feel free to ask me any question before I proceed. Okay, should I call names? Ayola, do you have any question?
Not yet.
Okay, Osazua, do you have any question at this point? Is it clear?
No. Yes, I'm following, sir.
Okay, thanks a lot.
Yes.
Okay. So we've spoken about like a few things. We've talked about distributed computing. We've talked about parallel computing, and we've also talked about virtualization. And I've been able to, at least to some extent, relate that to the things that you see every day. This material is available on so this material is also available for you. You can have access to this material at any particular point in time. If you don't have that link yet, please let me know, or I'll just talk to Emmanuel. Just send an email to Emmanuel on certification@Octave Analytics. He will grant you access, or he will help you to gain access to this. Okay, so all of this that we have talked about now led to a new concept of computing that is called Hadoop framework, and we are going to spend a lot of time to talk about the Hadoop framework this evening. So in order to manage all of these resources, so first of all, we've talked about different commodity computers that are connected within a network. We said that is distributed computing. We've talked about a computer that has multiple processors in it. Because it has multiple processors but it's sharing one memory, we said that is parallel computing. We said that a parallel computer can be connected into a distributed network. So which means that you have multiple processors and also have multiple memories connected together in a particular way, you know. Then we also talk about virtualization. So in all of this, how do you manage all of these resources together? Because it appears to be a whole lot of resources that need to be managed at the same time. So if you have 200 cars, if you have one train taking 1,000 people to Abuja, maybe it's easier to manage. You know there's only one train that you have to track at any particular point in time. But when you have 1,000 people distributed into 200 cars that take them from Lagos to Abuja, that means you have about 200 vehicles you need to track at a particular point. So when a car breaks down, you need to know, okay, this car has broken down, I need to replace this car immediately. Or maybe there's a flat tire on this particular car. You need to know that, okay, we need to look for a spare tire and replace this car. So it means that there's a lot of resources that you have to manage at the same time. So that led to the development of a piece of software or a concept. It's not a piece of software, actually. Hadoop is not a piece of software. Hadoop is a concept, or it's a framework, and it's meant to handle big data. It's meant to handle the volume need of big data. You know, it's meant to handle the analytical requirement of big data. It's also meant to handle the computational power requirement or the resource management requirement of big data. So Hadoop is an open source platform that is designed to work with huge data. So when you have a big data problem that is either structured or unstructured, Hadoop is that framework that is developed in order to be able to handle it. And it's open source. Originally, it was not open source. Historically, it was the Yahoo guys that designed it. So it was like a PhD program, PhD project for some bunch of Yahoo guys.
But after they have now developed Yahoo and they have made a lot of money from that concept, so they try to like release it into the open, under the open source license. They release it to Apache. So Apache is now the one that is handling the open source license for Hadoop. But some other people have taken that open source license, they've customized it to build different kind of version of the original Hadoop framework. With Hadoop, you can manage, you can analyze large volume of data, and you can get it done seamlessly because, of course, there are so many resources. Imagine you are connecting 200 computers together or a number of computers together. You need to be able to track all of this at the same time. Hadoop can help to get it done. And the way it does it is that it distributes the data efficiently and automatically across all the different computers that are available. And it also exploit the concept of parallel computing that is available within the CPU core. It has a simple programming interface, so anybody can actually program Hadoop. So if you set your mind that I can get this thing done, anybody can actually program Hadoop. There is a part of Hadoop that is kind of complex, but to a large extent, almost all the part of Hadoop, they are very simple commands that you can easily run to manage a Hadoop environment. Now, it works best. It works best when there is a large number of computers. So in this particular class, I think there are up to 10 people that are connected in this particular class now. So all of us, imagine we can connect all of our PCs together in such a way that if there's a task that needs to be done, instead of only one person's computer get that job done, that job can be displayed across all of our PCs. You can imagine at times you working with an Excel file and you want to open that Excel file, and that Excel file had to shut down your computer, or like it has to slow down your computer. You can simply not do anything anymore until that Excel file finishes loading on your computer, you know. But in distributed compute, in Hadoop system, Hadoop will take that job that you want to do, will take that Excel file and distribute the data itself across all the different servers or all the different pieces of computer that are connected within it. So this helps to improve the storage, how data is stored. So instead of storing it on a single computer, you can store the data across multiple disks. You can run the data across multiple memory. You can process the data across multiple processors. So, and then the Hadoop itself will now track, okay, which processor is available, which one is not available. So the example of 200 cars, if Hadoop is managing those 200 cars, by the time a car breaks down, let's say a car breaks down completely, that I cannot continue that journey to Abuja, while another car has already gotten to Abuja, that means the car that has gotten to Abuja is now available. The car can come down to pick the people that are stranded because of their car broke down along the way. So you need the system to be able to handle that. That is simply how Hadoop handles data. So it assesses, it improves data access, you know, because of the fact that all the data set or pieces of resources, they can be tracked. Hadoop is very, very resilient in keeping multiple pieces of data. And the way it is that for every single data, there's a snapshot, there's a copy of that data that is stored somewhere else. And because there's a copy of that data that is stored somewhere else, so even if the data crashes, the system does not have to like shut down, because the mirror of that data is available on another server that is somewhere. Processing improves, that is, the processing of tasks also improves, you know, things get done a lot faster. So I will explain one concept using our car example. Now we have 200 cars. In Hadoop, or in physical environment. In physical environment, 200 cars is taking 1,000 people to Abuja, 5 people in a car. But the way it is that in Hadoop, there is a copy of the data on another server. So which means that for every 5 people that are in a car, there is a copy of those 5 people in another car somewhere. Although it's not possible physically, you cannot have multiple copies of one person. but you can have multiple copies of data. So for every data, there are multiple copies of that data on another server somewhere. So in case one particular server is no longer available, then the server that has a copy of that data is just going to automatically continue functioning on behalf of the server that is no longer available. That is how Hadoop is designed. I think it will get clearer as we proceed. So Hadoop has 3 core components. There are 3 core components of Hadoop, and this component of Hadoop is going to help you to understand it a lot better. Number 1 is called the HDFS. That is the Hadoop file system. Number 2 is called the MapReduce engine of Hadoop, and the third part is called the, please, can you hear me? Hello, can you hear me?
Yes, we can hear you.
I can hear you.
Yes.
I hear you.
Thank you. So there are 3 key components of Hadoop. One is the HDFS Hadoop.
I don't know.
Your voice is not clear.
I can barely hear you.
You can barely hear me. Is that can you what about now? Can you hear me better now?
Yes, it's better.
Okay, thanks a lot. Okay, so there are 3 primary components of this Hadoop piece of software, and it's number 1 is HDFS. Number 2 is the MapReduce engine. Number 3 is YARN. YARN is an acronym for yet another resource negotiator. So the HDFS is like the storage location itself. It's like the storage location. That is the actual location where the data is stored within the Hadoop framework. That is HDFS, the actual location where the data is stored. MapReduce is an algorithm that divides a task across all the resources that are available and then combines the result again. While yet another resource negotiator, which is called YARN, is software that manages. It does housekeeping. It does housekeeping job. So we have 2,000. We have 1,000 people that we want to send to Abuja again, because this 1,000 people, we want to know. We have 200 cars that we want to put these people into to take them to Abuja. So in that case, we need to first of all track all the cars that are available. So you can use maybe the chassis number or the plate number to track all of the vehicles. That's number 1. Then you now have 1,000 people. You now be assigning 1 person to a particular car. So the seat where someone is sitting, is like the HDFS. So Blessing is sitting in the front seat of car number 1, or Blessing is sitting on the back in the back seat of car number 200. That exact location where the car is sitting, where the passenger is sitting, is like the HDFS. So that is the exact location where the file itself is stored, or where the data is stored on Hadoop framework. That is HDFS. Then you have the MapReduce engine. MapReduce engine is it's like that guy that is assigning, okay, you go to this particular car, you go to this particular car, you go to that other car, you go to this other car. So MapReduce is the guy that does those type of assignments. While yet another resource negotiator, YARN, is the one that will be tracking, okay, which car is available, which car has not broken down yet, which car has broken down, which car has lost its tire, which car has an engine problem. So it's tracking it so that whenever a resource is no longer available, okay, it will go and check, okay, which one is available, and use the one that's available to replace the resource that's not available. Simply, that is how it works. So also, in managing large amount of data, you need all of these different components to work together so that when there's a downtime, it does not appear to the user as if there's a real downtime, because another resource is quickly allocated to that task that user is currently working on. I'll pause a bit for like 1 minute, then we'll continue again. But feel free to ask me any question at this point. This is very technical, and that's why I use a lot of things that you can relate with to explain it. So please feel free to ask me any question at this point. Titilayo, please, could you ask me some questions, please? Remy is in the class. Remy, any question for me?
Hi, Blessing.
I think I've asked you question twice, so if I have any other one, I will still ask.
Thanks a lot. I had a lady's voice.
Yeah, this Hi, Blessing.
Hi.
Yeah, I actually joined very late. I'm just still trying to process all that you're saying. When I have questions that will ask.
Okay, so thanks a lot. So please, if you have any question, feel free to stop me at any particular point in time. The concept of computing, it's like our everyday life. It's like things that we see every day. So if you can at any point in time relate it to everyday life, you would understand, you'll be able to process it a lot. You'll be able to process it a lot better. If you have a job that needs to be done, that job needs to be saved on a particular file, needs to be loaded somewhere, So and there's some that you also need to be able to track where it is loaded, and someone also needs to track all the resources that are available in order to be able to get the job done. HDFS is where the job is saved within the Hadoop framework. HDFS is where the job is saved within the Hadoop framework. And MapReduce is what divides a task into a smaller task. So if there's a big data problem, MapReduce breaks it down into smaller jobs, and then assign it to the available resources. While once the job is completed, it combines the result into a single unit all over again. Then yet another resource negotiator, Yarn, what it does is that it simply tracks all the resources that are available, and it updates its memory in order to be able to tell which resource it's currently occupied or which is currently in execution, and which resource is available for the next job that needs to be submitted. So for each job, there's a job code that is assigned to each job, and by the time that job is submitted, the job code is what the Hadoop framework used to track which unit. So you have a big job is divided into a number of jobs. So the job code helps you to track that a particular job belongs to a task. This is difficult to explain now, but I'm going to try and break it down. So there's a job that needs to be done. So that job is divided into a number of tasks. So each of those tasks, somebody needs to track it and know that, okay, this particular task belongs to this particular job, because there could be a similar task that belong to different jobs. So a job code is what Hadoop used to track that a task belongs to a particular job. And then after the job is completed, or after the task is completed, is combined together into a single result, and then the result is presented back to the user. So which means that if we are going in group and we are a group of 20, we are a group of 20 within the 1,000 people. But now you have to divide these 20 of us into 2 different cars or 3 different cars. There's a way the system needs to be able to track us in such a way that by the time we get to the destination, it needs to bring us together as that one single unit, one single group, that has a particular mission, So that is how it simply works. So there's a task here. There's a simple task, and I'm going to call people just to sample their opinion and to check their understanding of everything we've been talking about. So we need to discuss how distributed computing will enable you to search, comment on social media. So if you need to search, comment on social media about a particular brand in the past 24 hours, how does distributed computing, how does it make it work? Who am I going to call? Let me see who I can quickly call. Babatunde, how do you think that distributed computing would help you, or how do you think distributed computing will enable comment search on social media? So if I go to Twitter is a social medium. So I go to and I want to search for election results. This is election result, and I submit. And then the results are out. You can see a number of results listed there. See a lot of results listed here. What did you think happened at the back end to facilitate it?
I think the various computers that were connected distributed the job among themselves. I mean, using a particular, of course, there is a coordinating software that distributes it and aggregate the result again and present it.
That is simply spot on. That is spot on. So I'm searching for election result. Yes, election results, and then you can see there's a result that came from SNBC. SNBC is a different server. There's another result that is coming from, I don't know where this one is. So there's another that's coming from Associated AP Politics. Another one is coming from Twitter. Another one is coming from different locations, different servers all over the whole world. So once you submit the tax is distributed across all of these different computers. They get the job done, and then they combine the result, in a particular way. So where the exact location, so if on Twitter, if all of this data is stored on, if the framework for storing this data is the Hadoop framework on Twitter, where the data is stored, the exact location where that data is stored is the HDFS. So when we submit our query to search for election results, what divides that job into smaller units and distributed among all the different computers is MapReduce. And if in case, for instance, maybe one of those servers is not available, or one of the location where the data is available it's not, if one of the resources is not available, it's Yan that goes to look for another resource, that goes to negotiate for another resource in order to get the results, out. So it's simply put, just as Babatunde put it. Thank you for that. It's a very simple question. So let me see if there's any other question. It says that search the internet. Okay, so there's a task for us here. You can read up Hadoop, what it is and how it works. So you can read up this particular article to get more information about how it works. There's another one about how Hadoop works, but this is it's a big data concept. It's a must know for every data scientist and for every big data practitioner. So feel free to read up all of these materials that are provided. One is Hadoop, what it is and how it works, by Brian Profit. And the other one is How Hadoop Works from Duke University. You can always read all of that up. Okay, so So in what way does Hadoop take distributed computing forward? So in what way does Hadoop take distributed computing forward? So the distributed computing, so let me answer that question. I will answer that question. So the distributed computing, it's more or less at the physical, it's at the physical layer. That is physical computers that are connected in a network. So what Hadoop does is that it helps to manage that distributed computing environment. It helps to organize it and make it more efficient. It brings efficiency. One word it brings efficiency to this distributed computing environment. That is one classical value added that Hadoop is bringing to distributed computing is efficiency. Efficiency, there is redundancy, and we are going to discuss this a lot more because what we've just had is like an intro into Hadoop. We are going to be discussing it a lot more as we proceed in this class. Okay, so let's talk about cloud computing. I'm sure a lot of you must have heard about cloud. It's in the cloud. I was talking to somebody yesterday, almost a complete novice. And she said to me, oh, it's in the cloud. So it's possible now if it's in the cloud, So a lot of us hear about cloud computing. So what exactly is cloud computing? Again, it's a method of providing shared computing resources that include application storage and computing. So how do you share computing resources in a way that makes it always available to guarantee that availability? In computer science, generally, there are three key resources that they try to manage. One of them is the processor, the other one is the memory, the other one is the disk space or storage space. Those are the three key resources that are managed in computing generally. So all kind of modification that you have, whether it is distributed computing, parallel computing, cloud computing, in-memory computing, is just a way to make all of those resources to be more available, to be able to handle bigger jobs or to get job done a lot faster than they will ordinarily get it done. So distributed computing is that concept that is introduced now to guarantee availability, availability of resources, of computing resources, whether it is application or storage or network, for over a wide range of users. Cloud-based applications enable availability of application, and it also lets you pay according to the resources that is used. This is a real life example. So before the lockdown in my company, we bought a server. We bought that server about 2 million naira before the lockdown, and we wanted to use it for a project. And immediately we're about to start the project, the lockdown started in April, and we could no longer use the server. We could no longer access the facility that is holding the server because of lockdown. The lockdown lasted like more than 6 months. We could no longer access that facility. Then we're wondering that 2 million gone down the drain, that we could have just like bought a cloud resource. We could have just bought a server in the cloud and then install our application in that server in the cloud and get our data loaded in the server in the cloud and build everything we need to build up there in the cloud. So really, and the way the cloud works is that we wouldn't have spent, by the time we would have spent 2 million naira, maybe 3 years would have gone past. By the time we would have spent 2 million naira for buying the same kind of resource that we bought for that physical server. So cloud server is guarantee availability, and to a large extent, it's usually a lot more cost effective than buying physical server. So if physical server is not being used, it's just going to be there redundant. But if a cloud server, is not being used, you don't pay anything. So some other people could just be using it while you are not using it. cloud today, it plays a very important role in big data world today because I gave this example last week. We were working with some guys from Shell, and they gave us access to three files of their data set. One file, the size of one file was around 360 something gigabyte. One single file was 360 something gigabyte. 3 files, it's about 1 terabyte. I don't have the kind of computer to load those 3 files. Before you can even load those 3 files, my PC would have, started giving me sign, start showing blue screen of death. But, with those type of data stored in the cloud, you don't even have to worry. You don't even have to worry so much because you can guarantee that the data is always going to be available. You can guarantee that anytime you want to use the data, you can just simply access it and get it done for whatever you want to use it for. You can be sure that there'll be enough memory up there in the cloud in order to be able to load the data. You can be sure that there'll be enough space in the cloud in order for you to be able to use to process those kind of data. So because the cloud environment is expandable. So as your data increases its size, the cloud resource that's available to you expands, and as your data shrinks, the cloud resources allocated to you can also shrink alongside. That is one of the. Please go on with your question.
Okay, so with what you have just said now, does it mean there's no disadvantage having a server in the cloud? If there is none, why do people, because even till today, people still tend to go for this physical server that's on-site, on-prem servers. Why do they do it? Because from what you have said, it seems to be cheaper, and it has more, you have more access and stuff based on your experience. Why do people still go for the physical server?
Okay, so all the banks in Nigeria, or almost all the banks in Nigeria until recently, we were doing on-premise. Number one is due to regulation. So the CBN regulation is that all financial data in Nigeria, for instance, must be resident in Nigeria. And because of that, and because of the fact that they also did not trust the local cloud infrastructure providers. So most of them decided to have their data hosted on premise just because they believe that they can control. It's because they believe that they can control things. But all of that is changing now. Some of those banks, they're also beginning to host some of their applications and data. They are beginning to host some of them in cloud. But the fact that the cloud is their cloud infrastructure providers in Nigeria, like Main One. There's Main One, there's one other one. I can't remember the name now. So number one reason is regulation. Number two reason is so some of them feel that because they have more control, they can be sure of security of their data than what is going through the cloud. Because if it's going through the cloud, it will be going through public internet, and if it's going through public internet, then there could be some fear of data security, and due to data security, that's why some of them decide to have their data on premise. Compliance issue. So there's compliance issue. I've talked about regulatory compliance. I've talked about data security. Then also in Nigeria, internet, you cannot compare the way internet is in Nigeria to the way internet is in the other part of the world. So because they always have almost available internet at a cheap, they have good internet, so to say. So the experience is not significantly different between when you're physically working on your computer and when you are working in the cloud. But in Nigeria, where at times internet can be down, how many times in this year have you heard a bank said, I'm sorry that we are sorry that our systems are not available at this time? I've seen like maybe 3 or 4 banks in the past 1 month apologize for their system going down. They've had outages, and it's because of maybe internet issue. There can be a fiber cord somewhere that made it difficult for people to be able to access their server. So that's why that dependency on internet resources make most of them to say, okay, let's have this thing on our own premise where we can control it rather than having it in the cloud. Then there is also cost. So at some point, it can actually be expensive at some point. It can be expensive. There are some kind of processes you may want to do in the cloud that it will be a lot cheaper for you to have it on premise. There are some cases like that. But in most cases, the cloud infrastructure is cheaper, and it's pay as you go. Is what you need is what you pay for. What you don't need to pay for. You don't need to pay for it. For 6 months that we did not access the server that we acquired, those 6 months, if we're not working in the cloud, we will not need to pay for those resources. So those are some of the issues I think affect on-premise adoption in Nigeria. I don't know if that answers your question.
Yeah, perfectly. Yeah, it does.
Okay, so the cloud. So in the cloud, there are different kinds of resources that can be hosted in the cloud. It could be software as a service in the cloud. So when you have like Microsoft Teams that we are using now, this Microsoft Teams is a software as a service in the cloud. So we are using Microsoft Teams to do online class. It's a software. It's hosted in the cloud. All I just need to do is to connect my computer to that Microsoft Teams, and then it makes me, it like launches me where people can access me. There are things like Google Excel. There's Google Docs. There's Google Spreadsheets. So I can go and work on a Google document and save it in there in the cloud. And somebody else that somewhere else can go and also modify that same document if I grant the person access. Those are software that are available in the cloud. There's a lot of software that is available in the cloud. Your Microsoft Word before now, when we were growing up, Microsoft Word on Windows XP, all of those things, they were only going to work on your computer. But today, you can go online and do a document, write a letter in a cloud, and then also upload it or share it or grant access to other people just right there in the cloud without having a snapshot of it installed on your computer. You have infrastructure as a cloud. The infrastructure as a cloud is server. So you want to buy a physical server. You can go and buy a cloud infrastructure, in such a way that when you need to install your application, everything you need to do, you just deploy it on that infrastructure that you have bought in the cloud. What it means is that you are not going to have any physical server within your premise. So that the example that he asked just now. So most of the kind of infrastructure that some of these companies they buy, they are cloud infrastructure in such a way that any deployment they need to do, they do it on that infrastructure in the cloud. Then you also have platform as a service. So that platform, you have something like Microsoft Azure, which is a combination of multiple resources put together. So that's like a platform. It's like a platform. So on that platform, you can have almost all the resources that you need, maybe for machine learning, for visualization, or maybe for database, or maybe data lake, all of them. You can have everything put together as a platform and you host it in the cloud. So anything that you need, it's just available within that platform. So it's not just a piece of software now, but like a collection of multiple pieces of software all together. So cloud allows scalability. I've said it before. Elasticity. as I say, provided that the elasticity limit is not exceeded. The way cloud is structured, they keep adding more physical resources to the cloud in a way that it is expandable. It's expandable. It's expandable depending on your demand for that resource. You can simply just scale it and expand it. It does resource pooling, which means that it allows multiple organizations to share the same computing resources. So you can have a GT Bank and a Unity Bank and a First Bank. They can be sharing the same infrastructure on main one, but they don't even know that they are using the same infrastructure, because with the concept of virtualization that we discussed earlier on, it will just appear to them as if it is the whole infrastructure is available to them. But in the real sense, they're actually pulling resources together and they're sharing the same infrastructure. To a large extent, it is self-service. So they have functionalities that makes it very easy for you to be able to manage stuff by yourself. For some of us that used to do programming many years ago, you remember that if you want to do some program, you have to buy, you have to install that app, you have to install an application on your computer, develop the program. After developing the program, then you now find a way of hosting that program that you have developed. But this day now, you can just go to the cloud and just drag and drop tools from here and there, and you have built an application. And after building it, you publish it. After you publish it, it's already available. So for those that do content management, maybe before you used to have things like Dreamweaver to help you to manage your content, but today you can just go to WordPress. WordPress already has almost all the templates you can possibly want to use. You just have it, you go there, look for the right template, put your content in there, publish it. Without installing anything on your computer, you can design a website. All of this is facilitated by the concept of cloud computing. It is low cost. It is usually a lot less expensive than that physical infrastructure in most cases, except in some very rare cases. And it's fault tolerant in terms of although we heard recently, there was a news yesterday that Amazon was down. Yeah, AWS was down. No, not the whole AWS, not AWS worldwide went down, but the east node for AWS went down. Well, it may be a fiber cut, it may be some network access that made it to go down, but in most cases, you rarely hear that. You hear that only once in a while. You hear things like that once in a while. Unlike for some of you that use some bank, you want to do your mobile banking application, and they'll tell you that, oh, sorry, it's not available for now. You rarely hear that a cloud computing resource went down. You rarely hear it, because the way the architecture or the way it is designed, there is failover and there's no single source of failure within a cloud infrastructure. Okay, so so in terms of deployment, there are two types of deployment for cloud infrastructure. And this also ties to the question that someone just raised now, that why are companies going for on-premise solution? So a lot of them are now adapting from on-premise. They are now creating their own private cloud. So a company can also decide to have its own private cloud deployment in such a way that all its resources, they are available in the cloud, but that cloud is not the public cloud like AWS or Google Cloud or Microsoft Cloud. The public cloud is owned or operated by companies like Google, AWS, Microsoft. Things like YouTube is on the public cloud. Things like Vimeo is on a public cloud. Things like Twitter is on a public cloud. While the businesses, for businesses, the public cloud provides economic storage. So like all the videos for this class, for all the classes we've been having now, we can go and upload them on YouTube. You know, it's a cloud facility where people can go and access it. Imagine what it will cost us if we decide to go and set up our own YouTube by ourselves, where we have to be uploading videos. It's not that it cannot be done, but it will be a lot more expensive if we have to go and get that done by ourselves. It will be a lot more expensive than just go to a public cloud facility like YouTube and then upload all the video, and people all over the world can access the video for our classes, you know. And the public cloud customizes hardware and software in order to be able to optimize performance. So at the back end, there is a lot of optimization that is happening at the back end in order to drive optimization. For private cloud, for private cloud, it's owned by a private company like banks, like data security companies can own a private cloud, and but those clouds will be governed by their own policy. There'll be data governance framework that is guiding how they access data in their own private cloud and how they modify data in their own private cloud. You know, it's not anybody, it's not going to be accessible to anybody, and there's going to be ownership. Somebody owns it. It's not publicly available. It's not anything that you can just go there and host in that particular. Okay, so there's a bit of pause, but please, I want you to confirm if you can hear me. Can you hear me? Hello,
Yes, we can.
Okay,
Yes,
thanks.
we can.
Okay, thank you. As I said earlier on, there could be infrastructure as a service in the cloud. There could be platform as a service in the cloud. There could be software as a service in the cloud. When we say infrastructure as a service, that's like you can have like a physical server, like what you buy as a physical computer server, hardware, storage or network. You can have it hosted in the cloud. You know, you can have platform as a service, things like Microsoft Azure, or there's Google Cloud is a platform. That Google Cloud is a combination of many resources put together. I'll show you an example. So look at where is that stuff again? Where's my Google? Okay, look at this. So on Google, you can see this. So you have YouTube, you have Google Map, you have Google Search, you have Google Gmail, you have Google Drive, you have Google Play, you have Google Calendar, you have images, you have photos. All of this, this is like a platform. So this is like a platform, which is a combination of so many resources put together. So that it's a platform as a service. You know, it's not just like a single piece of it's not like a single piece of a software. There is SaaS, enterprise miner. Yeah, enterprise miner cloud. So this is like a software in the cloud. Let me see. Yeah, so I think this is like a software in the cloud. SaaS enterprise miner is a predictive modeling tool. It's a predictive modeling tool. So you can access it. It's like a software. You can see software in the cloud. It's like a predictive modeling software in the cloud. You know, it's a software. It's a piece of software in the cloud. Then you now have that is software as a service. Then infrastructure as a service is how do I explain? AWS. If you come to AWS. So in AWS, you can see a host of infrastructure as a service on AWS. It's loading. Yeah, it's loading. If I log into my account, you can see a number of infrastructure that you can buy on AWS. So simply that differentiates all the different type of resources that can be available in the cloud. So yeah, so these are examples of These are examples of cloud service provider: Amazon, Google, and Microsoft. Those are examples of cloud resource or cloud service providers. So please, I will also pause for another 1 minute for you to ask me questions. Let's have some interactions. Let's have some discussion around cloud technology. Have you done anything in the cloud before? Do you have some data that you have loaded into the cloud before? Can we have some discussion around that? Is there anyone that is in this class that have uploaded data into the cloud before? Tell us about your experience. Tell us about the advantages you think that having a cloud environment brings to you. So that is an open question to the house. Okay, so you probably have loaded things in the cloud before. So so recently, okay, someone want to answer that?
I wanted to add something. Should I say add or answer?
Oh yeah, please go on. Please.
I don't know if backups, like when your pictures or your files are being synchronized, you have a backup like your pictures, like on iPhone and on, I can't remember the name now, OneDrive.
Yes.
Yes, one time I had most of my pictures on OneDrive, and I lost my device. I was able to regain them. Is that cloud computing?
Yes, it is. It's cloud computing. So remember when we were a lot younger, when phone just came to Nigeria, then if you lost your phone, you lose all of your contacts, you know. But today, your Android phone, your Android application or your iOS application is a cloud-based application. So each time you store a contact on your phone, it quickly synchronizes with your contact on Google or your contact on iOS. And the advantage of that is that if you lost your phone or your phone crashes or anything happens, just get a new phone, enter your email address, it automatically downloads all your contact up until the last contact that you save. It downloads it on your phone. You don't have to start moving contact. You don't have to start writing contact on paper. That is a cloud. It's a cloud concept. It's a cloud concept. So, so where your data is stored in the cloud, you may not even know exactly where your data is stored in the cloud. Your data may be stored in the cloud on the same location where, say, that guy in your street that you don't like, for instance, may be stored exactly on the same location on Google Cloud, you know. Those contacts may be stored on exactly the same location. But who even cares? The fact is that immediately you swap your phone or you swap your SIM into a new phone, automatically your contacts, it's downloaded into your data is downloaded into your phone. That is the concept of cloud computing. Then also this PC that I'm using, I've been using it since 2016. Then I was at a point, I just knew that this PC is already giving me warning sign. I just got about 1 terabyte space. I got 1 terabyte space on Google Drive, and I pushed everything, every item on this computer, I push it into the Google Cloud. And I can be sure, and the way I did it is that it synchronizes automatically. So if I create a new file just right now, after a while, the file will just synchronize with the cloud environment. So what it means is that anything happens to this PC, I can be rest assured that my files are intact. That is the concept of cloud computing, and that can also be applicable into managing databases for your company. It can be applicable into managing applications. If you want to build an application, you can have it loaded in the cloud in such a way that if you lose a PC or you lose a server, okay, if you lose a PC or lose a server, you don't lose anything per se. There are some hybrid implementation, just to also address the question I had earlier on. There are some hybrid application in such a way that there is a server on-premise which is connected to the cloud. And the way it is done is that anything that hits that server is automatically also pushed into the cloud. And why that is important is that it's like backing up the content of that server in the cloud. So if the server is no longer available, you can be sure that you can quickly fail over to the cloud infrastructure. So you also have a situation where you can have hybrid of on-premise and cloud sit together.
So then, in addition to that, I look at it from another angle of maybe a company trying to work with another company, maybe as a vendor, a contractor, and you have your server sitting in the cloud. You don't really need a physical server there. Your contract could be for a year or two. After that contract, then you need to start going back to on-prem to take your server out and stuff like that. But if you have it in the cloud, you just move on. You don't really have issues of getting all of those physical servers out of there. I think those are the part of the advantages. If
So this is a new, there's a so for that contract that you have, the data that you're working on for that server, who owns the data? Are you the owner of the data or the client that you're working for? If you are the client, if it's the client that owns the data, you cannot move that server.
no, the client owns his data, yeah.
Yeah, so if the client owns the data, you cannot move the server. Go on.
Okay. Yeah, so the client owns the data, but I think there are some kind of synchronization that needs to be done along with your own, maybe the technical. I'm not really a technical person, but the technical part of it. So there are cases where I see that even those guys are not even in this country, and things are moving on so fine. And you just find out that okay, they have stuff seated in the cloud.
So two things are considered, and this is very, very important for this conversation. There is a regulation, or there is a data governance framework that guides data interchange or data integration between two different systems. So if you work on a project and you work with some server, maybe some physical server, if your client data is on that server, you cannot move that server out, except maybe it is certified. Maybe somebody comes and formats that server and wipe off everything that's on that server. Otherwise, you cannot move that server out of your client environment. That's number one. So if that data is in the cloud, the way it is that it's even the client that is going to own that cloud account. So you cannot use your own personal account, because again, data is the next most important thing after customer. Yeah, data is the next most important thing after customer. Anybody that has your data.
The example you gave earlier about the server you put and you're unable to use, does it mean if you undo that contract, you will not take the server back? And you just mentioned that you used your 2 million naira to buy the server. Will the client pay for it?
We did not. Yes, we did not. We did not. The example that I gave that we bought a 16 core server. We did not.
Meaning that you don't have taken.
Go on, Eric.
I mean, if you have used it, it means that you wouldn't have taken the server off the customer's premises after using it.
My answer to that is yes. We did not move it.
So will it be the 2 million?
So two things. The answer is yes. So you might get. So one thing is that you can get the customer to pay for. You can get the customer to pay for that server. So you would have probably built that cost into your commercials for the project. You'd have built that cost into the for all the projects we have done. We've done more than 10 projects. We did not leave any project and then now move the server out of that client environment. So what we do is that even from two ways. Number one, you might be the one that will buy the server. We've had like 3 cases where we bought the server. We did not move the server out of client environment. But in most cases, we tell the client to buy the server. The only problem is with that is that at times they delay us because they may not know. You want to just get started immediately now. So you want to go and buy server and deploy server and start working. You understand? But they may delay you. But in most cases, what we ask them to do is that you buy the server. If it's going to be a cloud infrastructure, we are going to use your own account. So you buy the cloud infrastructure that we need in the cloud. Then we use that for deployment. That is how we do it. That is how we do it now. But in cases where we have bought physical server on premise till today, we don't even have that discussion about moving it. You want to move people's life out. You don't have that discussion. Or let's say you have a vendor that work for you. You now say you want to move your server out. The guy is moving your data out. You don't allow that. So simply that's how it's been for us. We don't move those servers out. It's already given out. So do you think an organization size? Please, if you have any discussion, if you have any question, please feel free to ask. Feel free to ask. I'll be glad to answer your question. And I don't know, maybe Eric is satisfied with the answer that I gave, but I want to tell you, for all the projects that we have done, we have never moved the server out. That is a fact.
You
It wasn't
calling
me.
me
It wasn't
Eric.
Eric that asked that.
You have been calling me Eric since Monday. I'm Aderemi.
I'm sorry. Your voice, I'm sorry, I'm not seeing the, I'm sorry. Yeah, okay. Thanks, Aderemi. I'm sorry. Okay, so do you think the size of an organization is a factor in deciding whether to use infrastructure, platform, or software on the cloud? So who am I going to ask this question? I'll just check who is on the line. Okay, so I will ask a lady. I need a lady's voice. Let me ask. So there is Dorcas on the call, and there is Susan on the call. Let me go to Susan. So Susan, do you think that the size of an organization is a factor in deciding whether to use infrastructure or platform or software in the cloud? Do you think the size matters in determining whether you want to use a cloud infrastructure or not? Susan, are you there? Okay, so Susan does not want us to hear her voice. Dorcas, can you answer that question? Okay, so Dorcas, can you hear me? Okay, Anthony, please go on.
That's Aderemi.
Okay,
The answer to that could be a yes and a no. A company size and the data capacity of what they want to store could influence their decision about using the cloud. So yes, because the company might be big, but they are not a company that keeps records of so much data. And I would say no, because you need to keep it safe, irrespective of the amount of data you want to keep or the size of your company. Any data you lose could make or mar you. So any data you lose could mar your company. So it's irrespective of the size of your company, as long as no matter how small the data is that you want to keep in the cloud, there is space for it up there. So your size should not matter.
So why you answer that question well is that the question requires you to rationalize. And I love the way you have rationalized that question. But you didn't get the answer, but you rationalized very well. Actually, the answer is no. So your size whether you're a big company or you're a small company, whether you are working with small data or whether you are working with big data, cloud is a home for everybody, you know. Whether you are big, whether you have 1 million, maybe you have 200 million contacts on your phone, or you only have 15 contacts on your phone, you can always synchronize your contacts in the cloud, you know. So the size of an organization does not really matter in terms of choosing infrastructure in the cloud. So if your size is big, the infrastructure requirement, it's always, most of the time, it's always going to be cheaper than having infrastructure on premise, because if your company is big, that means you are going to also require a lot of infrastructure. So as much infrastructure that you're going to need, the cloud environment is going to offer you a cheaper alternative.
What of communication costs?
What of what?
Communication costs.
Like data, internet cost, Abi.
Yes, link.
Yeah, so even if you have it on premise, it still does not take that away. Even if you have it on premise, it still does not take it away. So this is the way it is. If you have it on premise, maybe you require people to always travel. You said you cannot hear me? Hello, can you hear me? Hello?
I can hear you.
Yes, I can hear you. I can hear you.
Thank you. So if you have it on premise, so look at work from home. Since we started working from home, it's actually cheaper than going to the office every day. So that cost is transferred to somewhere else. You understand? So if you are spending cost on internet access, you are saving costs from somewhere else that you are now spending on internet access, and the aggregate of both, it's actually going to be cheaper for you to be on in the cloud in more often than not. It's always going to be cheaper. So regardless of the size of the organization, you can always be in the cloud. Okay, so thank you for making the class very exciting and very interactive today. I think I enjoyed that back and forth, those interactions. It enforces learning. I wish it to be this interactive. Tomorrow. So today I'm transmitting from Abuja. I'm transmitting live from Abuja. This time last week it was in Lagos. It was in the office in Lagos, but today it's from a different location in Abuja. That is where this class is transmitting from. So tomorrow I'm still going to be in Abuja tomorrow, but at our facility in Yaba, it's going to be open for those that want to come and download the virtual learning environment and load it on their PC. So the facility is going to be open tomorrow. So please feel free to come around to class tomorrow. We are going to be open tomorrow. Then also the office in Abuja is also going to be open tomorrow. So for those that are in Abuja that also want to come around, our office is in Kado, opposite LG shop in Kado. So you can also come around come around tomorrow. It's supposed to be a hybrid class. So Saturday classes is supposed to be a physical session, but then people that cannot physically present, they can connect remotely. So please, if you have any question, please feel free to ask me at any point in time, whether it is in class or outside the class. And yeah. So, but it's on this note that we are going to be ending the class today if there is no other question. But if you have any question, I'm still available to entertain your questions. Thank you very much.
I'd like to make a suggestion, not a question really, just to solve. Can you hear me?
I can hear you clearly.
Okay, to solve the problem of mixing up names. I think if anybody has a contribution, he or she should just first introduce him or herself that, okay, I'm just so person. then proceed to ask or contribute.
Okay. Okay. Yeah, thanks a lot, Eric, for that.
Eric, yes.
So now I switch. I can switch to the platform. I can see people's name. When I'm sharing my screen, I don't see people's name.
Okay.
I'll just find a way of figuring that out. But thank you for that feedback, and thank you for attending the class today. Please, if you have any question, I'm still on standby. I'm still going to be connected to this class, and the recordings for this class is also available for anybody that wants to access it. We are going to upload it. We have a YouTube channel. We upload it on the YouTube channel, so you can always go back and refer back to it. Thank you, everyone.
Thank you. Bye.
Thank you.
Thank you so much. Thank you.
Thank you.
Thanks.
Thank
Bye-bye.
you.
Thank you. Bye.
Hi, Blessing.
Thank you.
Just take care. Thanks.
Hi,
Bye.
Blessing.
Thank you. Thank you.
See you tomorrow, sir. Thank you.
Bye. Yeah.
Hi, Blessing. Can you hear me, please?
Take care. Bye, everyone. Thank you. Titi, you are still connected.
Yes, Blessing. I wanted to ask you a question. I've been speaking since, but it seems you're not here. Probably it's network.
I knew you have a question. I'm here for you.
Okay, in the study pack, the book one, we have
Yes.
knowledge check questions, but no answers to know if you're right or wrong. So I was
Yes.
wondering if the answer is somewhere else.
Yeah, so the way they did those the way they did it, there are answers to some of those questions in the next chapter, and some don't even have answers at all. In some cases, some of those questions they are open-ended, where there is no right question, where there's no right answer or a wrong answer. But most of them, even though the answers were not provided explicitly, but the answer is in that material. As you continue reading the material, you'll find the answer to some of those questions that they raised.
Okay, no problem. Thank you very much.
All right. So sorry, I'm not going to be around tomorrow, so you might not see me tomorrow, but Emmanuel is going to be around so that I can copy the virtual learning environment.
All right, that's fine. No problem.
All right, cheers. Take care. Bye.
All right,
Good
bye.
night,
Thank you,
everyone.
bye.
Ayola, Smiler, and Remy. Good night.
Good night.